right? So we've discussed about chord properties, okay, like the geometrical chord properties on a circle, okay. Now we want to talk about the tangent property, okay. So what is tangent again? It's the line that touches on the circle, the circumference of the circle at only one point, okay. So I'm going to create a new okay, there you go, it's showing up. Okay, so I'm going to create a new circle. Okay, so you also need to draw a circle, okay, with center O. So I'm gonna change this before I forget. Okay, it's kind of like standard, you know, a circle with center O. Okay, and we want to draw a tangent line, okay, with a contact point at X. Okay, so I'm going to draw a tangent line, okay, at X, and this is my X, okay. Is everyone done with this? Okay, everyone has drawn this circle and line touching on a point at X. Good. Okay, so now we want to draw a line connecting to the center O and point X. So I'm going to connect O and X right there. Okay, so using your protractor, measure the angle OXD and OXC. Okay, I'm going to use my protractor from here. Okay, and what do you get? You get 90 degrees, okay, angle OXD, and of course the other side will be also 90 degrees. So what can you say about the line OX and tangent CD? That they are perpendicular. Very good. So this is from our drawing, right? And how can we really prove it? Okay. So let's say we have a chord, okay. We draw a chord. Let's see how do I do this. That is parallel to okay. So there's a chord that is parallel, okay. And what do we know about the chord and a line that's perpendicular to the chord? They're bisecting, right? Passes through the center, okay. And so if I bring this down, okay, wait a second. Okay, so if I bring this chord I want to move. Come on, I want to move. Okay, so imagine that I'm bringing this chord down, 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 down to here. Okay, I'll get 90 degrees, right? Okay. Now, the second property, okay, of tangent will be drawing a circle with center O, okay? And then pick a point P outside of the circle. Okay, so let's walk through this. Okay, so I have a circle with center O. Okay, and then draw a point P outside. Okay, and then we want to construct two tangent lines from P touching the circle at A and B. Okay, so it touches here. Oops. Okay. Just making sure that it's right there. Okay, so there's a point P touches the circle as tangent at point A and B. Okay. All right. So what can we say here? Let's take a look at some of the elements here. We have the distance of P and A. Okay, so that's 4.22. And how about P and B? Oh, it's the same. Okay. There you go. All right. Now, how about if I draw a line here? Okay. And then what can you say about the angle? Should we look at the angle? All right. So let's check the angle. APO is 30.92. Okay, let's put it here so it's clear. Okay, how about BPO? Okay. Anyone want to guess? There could be equal. Okay, so let's try that. Okay. And yep, they are equal. Okay. So in general, okay, tangents from the external points are from the same external point, right? They are equal in length, okay? And the line from the center to the external point, what do they do to the angle? They bisect the angle, okay? They divide them into two equal parts, okay? There you go, okay? All right. Any questions? And any confusions here? If not, then let's move to an example. In the figure, PX is a tangent to the circle with center O, okay? Given that PX is 6.8 centimeters and OX equals to 4.3 centimeters, find the angle OPX, okay? The length of OP, the area of the triangle OPX, okay? So this is the visual of the question. So for the first one, we want to look at find the angle of OPX. What do we know here? So from the property that we just learned about tangent is that OX and PX here are perpendicular, so OXP is 90 degrees. And so in a triangle OPX, okay, we can use trigonometry, okay, the trigonometry ratio to find the angle OPX. All right, what do we use here for the angle right over here? Okay, so for the angle here, what do you use? Tan, right? Okay, so for tan, it's 4.3 over 6.8 equals to tan OPX. Okay, and so to find the angle OPX, we need to do arctan. Okay, on your calculator. You know how to do it, right? Okay, and then you will get 22.3. All right. So next one, in the triangle OPX, okay, we want to find OP, and we can use Pythagoras theorem. Okay, so 4.3 square plus 6.8 square equals to OP square. Okay, so OP will get 8.05 centimeters. Okay, and last one, we want to find the area. Okay, since we already know this is right angle triangle, okay, we have the base here or the height here, so we can just use these two values to find the area. Okay, so half times px times ox equals to 14.62 centimeters squared. Okay, don't forget the unit, right? Next example, okay, in the figure, PA and PB are tangents to the circle with center O. Okay, given that OA equals to 8 centimeters and angle OPB equals to 26 degrees, find angle of AOB, okay, and then the length of AP, here, okay, and then the area of the quadrilateral APBO. All right. So the first one, we want to find the angle of AOB. We need to just draw all the things that you know first. Okay, so this AOB right here, OAP here is 90 degrees. Okay, OPB here is 90 degrees. Okay, and what else do we know? We know that OPB is 26, so OPA is, yes, also 26. Okay, so 26 right here, this is 90 and this is 90. Can we get BOP? Okay, so it's 180 minus 90 minus 26 equals to all right, and then, or we can use the sum of quadrilaterals, which is the total of the interior angle of a quadrilateral is 360. So we can just do 360 minus 26 minus 26 minus 90 minus 90 equal to 128. Okay. The second one, we want to find the length AP. Okay. So we already know the angles, right? Almost every angles here, the interior of the triangles and all quadrilaterals here. We already know all the angles, so we can use tan, right, to find the length of AP. So tan 26 equals to 8 over AP. Okay, so AP equals to 16.4. Okay, the last question is to find the area of the quadrilateral. Okay, so we can first look at the area of the triangle APO. Okay, APO is half times 8 times 16.4, okay, equals to 65.61 centimeters square. And then, so the area of the quadrilateral, we just need to multiply by 2 of the triangle. Okay, so 2 times 60.61 equals to 131 centimeters square. Okay, so that would be the example. Do you have any questions for this? Nope. All right, so we are going to do exercise. All right, everyone, thank you for your participation today. I will see you next class. Bye.